Unit 1B, Lesson 3, Creating Equations to Solve Problems. To start this lesson, it's going to be very similar to what we talked about in the previous lesson. We're going to take some information and write an expression that represents that situation. Then towards the end of the lesson, we're going to talk about exponential functions, and we're going to take a situation, create an equation, some type of exponential equation so that we can solve those problems. Now to the first example. If h represents a number, which equation is a correct translation of 60 more than 9 times a number is 375? First, before we create the equation, we need to take this statement and pick out some key words and understand what those words or phrases mean. So the first one is more than. More than indicates we're going to have addition somewhere in our problem. We also have times. Times is going to be multiply. And then we have the word is. And whenever you see is in a phrase like this, that's where our equal sign is going to go. So we have 60 more than 9 times a number. We're going to let h represent that number. So we're taking 9 times h, 9 times some number. We have 60 more than that quantity. So we have to add 60 to it. Good plus sign. And that is going to be equal to is 375. So 60 more than 9 times a number is 375. We have 9 times h plus 60. 60 more than 9 times some number is 375. Now to the next example. If n is an odd integer, which equation can be used to find 3 consecutive odd integers whose sum is -3? Okay, so first we need to understand what an odd integer is. You should know what odd numbers are. You should know what integers are. So examples of odd integers: -3, 5, 13, 17. So basically it's an odd, positive, or negative whole number. Next thing we need to identify is what sum means. Recall that sum means that we're adding quantities together. Okay, so which equation can be used to find 3 consecutive odd integers whose sum is -3? Well, for the first one, our first odd integer is just going to be n. We let n represent an odd integer. We have to add to that the next odd integer. Well, if we took that odd integer, just say that was 3, if we added 1 to it, we would get 4, which is an even number, so that's not going to work. So we have to take our odd integer and add 2 to it. Okay, so think about this. If this was 3, then we would have 3 plus 2, which is 5. So 3 plus 5, those are 2 consecutive odd integers. And then we also have to add the next odd integer, which would be n plus 4. And we're told that sum, that total, is -3. Since we just have addition going on, we can just get rid of these parentheses around those expressions that represent those consecutive integers. So now we have n plus 2 plus n plus 4 equal to -3. N plus n simplifies to 3n. 2 plus 4 simplifies to 6, equal to -3. Okay, so now we can actually go through and solve for n. We would get or subtract -6, subtract -6. 3n is equal to -9. We would divide by 3 to get n equals -3. So now, if we go and take our 3 consecutive integers, our first one is -3. We're going to add to that -3 plus 2, which would be -1. And then we're going to add to that -3 plus 4, which is +1. And that result has to be -3. Well, -1 and +1 cancel out, so we're left with -3 equal to -3, which we know is true. Now we need to talk about exponential functions. The most basic form for an exponential function is y equals a times b to the x power. A represents the initial amount, and B represents the base. It's essentially tells us whether we're going to be increasing or decreasing. What we're going to work with right away are two special types of exponential functions. We have exponential growth and exponential decay. There's lots of story problems, science applications we can do with exponential growth and decay. For the exponential growth equation, we have A equals P times the quantity 1 plus R raised to the T power. For exponential decay, the only thing that changes is instead of adding, we're subtracting that rate. Okay, so now off to the right, you can see what some of these values represent. A, like I said before, is the initial amount. B is the base. P, the capitalized P, is the principal, which is essentially the same as the initial amount. When we're talking about application problems, the principal is referring to the original initial amount we start with. R represents our rate, which when we put it into the equation, we always want to write it as a decimal. So if we're given the rate as a percent, we first have to convert that to a decimal. And then T represents time. And we're going to assume the time is in years unless we're told otherwise in the problem. Okay, capital A just represents the amount we have at the end after we have the rest of our information. Okay, it's essentially the same as Y. It's the value we're trying to find. Now to the first application problem. Sheba opened a retirement account with $36,500. Her account grew at a rate of 7% per year compounded annually. We'll talk about what this compounding means later on. She made no deposits or withdrawals on the account. At the end of 20 years, what was the account worth? To the nearest dollar. Okay, so first, since this is a retirement account and we can see that it grew, this is going to be exponential growth. So our equation we have to use is A equals P times the quantity 1 plus R raised to the T power. So we're looking for the value of A, the amount of money in the account at the end of the 20 years. So we need to identify what P is, what R is, and what T is, and plug that into the equation. So we have A equals P represents the principal amount, which is the initial amount, which in this case is $36,500. Then we have 1 plus R represents our rate, which we could see is 7%. When we plug that into the equation, we have to convert it to a decimal. So 7% as a decimal, move that to place values, 0.07. And then T represents our exponent, which is time in years, which is 20. Now we would just take and plug this information into a calculator to find that approximate value. Once you plug that into a calculator, the approximate value you get is $141,243.48. So the answer we would select up here is number 3. That is to the nearest dollar. Normally when we're talking about money, I'm going to have you round to 2 decimal places when we get those answers. Okay, so key part, it was growing. It's a retirement account, so we have to use exponential growth. Identify the necessary values we need. Make sure to convert our rate to a decimal when you plug that into the equation. The next application problem, Daniel's print shop purchased a new printer for $35,000. Each year it depreciates, loses value at a rate of 5%. What will its approximate value be at the end of the 4th year? So in this case, we see it depreciates, it loses its value. So this is going to be exponential decay. The equation we have to use is A equals P times the quantity 1 minus R raised to the T power. The only thing that changes is instead of adding, we now subtract that rate. So we write our equation. A is equal to the principal amount, the original amount is $35,000. We have to multiply that by 1 minus our rate is 5%. We convert that to a decimal, 0.05, raised to the T power. We're looking for its value after 4 years. So now we have our equation. We just plug this into a calculator to get that value. Once you plug that into a calculator, the approximate value you should get is $28,507.72, which would be option 3 up above. So in this lesson, at the beginning, we talked about how to write equations when given word statements. And then towards the end of the lesson, we talked about exponential functions. We talked about the generic form y equals a times b to the x. And then we also talked about the special equations for exponential growth and exponential decay when dealing with application problems. So make sure you know those formulas and know what all of the variables values represent in those equations.